Hello and welcome to the tutorial mechanics of materials. So now there is a problem. So problem is a vertical circular steel of length 3L fixed at both of its ends is loaded at intermediate sections shown in figures. So here what are the loads which is applied for a particular sections that we need to define. So what are the forces each sections experienced? That is the goal to define. So here, how to define this? Let's see. Here are three sections connected together, and after making connections, it's going to fixed at both the ends. And each section having length L, and intermediate forces is applied at point B, a force applied 2W, at point C, force applied W. So for each sections, what are the exact forces that we are going to define by using principle of superposition? So let us see. Suppose at point A in section 1, a reaction R is applied. So here, assuming a reaction R is applied at point A, as this is fixed, so due to fixity, our reactions will be developed. And how we are going to deal? Suppose reaction R is developed. So here R is given. Next, what will happen? To maintain the equilibrium of these sections, at the next side or at the next end, similar reactions will be there. So this member will be under equilibrium. So this is the first members as we selected. Next, see the second member. Second member, as a point B, R is applied in that reactions. Here also at point B, R is applied. This is point C, B and C, B and C. And one more load is applied. So here, now applying a principle of superposition. So for one reactions, this section is given. For another load, which is 2W, is shown in the figure in compressive in nature for section 2. So this is compressive in nature. Now adding both the forces, here positive R and negative, because it's tension force positive, compressive force negative, R minus 2W. Again, to maintain the equilibrium conditions, at the another end similar force will be applied, so R minus 2W. So for section 2, whatever the load is going to apply, it's decided by using principle of superposition. Again, for section 3, as we calculated at the one end of section 2, that force R minus 2W is applied, that is tangential in nature. So in that reactions for section 3, at point B, at point C, similar force will be applied, CD, CD and CD. Here R minus 2W, similar force will be applied, but at the point C, here again a compressive nature of force W is applied. So let us add this force also. So by adding this force W, again we are going to sum up these two forces. So here R minus 3W will get. So to maintain again the equilibrium, at the another end at point D, R minus 3W will be applied. Next, as both end is fixed, the elongation is 0. So here forces are calculated for each section. So now both ends are fixed, so elongation will be 0, means that section is not going anywhere, it's not going to expand, it's not going to contract. So what will happen? Means sum of elongation for each sections will be equal to 0, means overall elongation will be equal to 0. So now apply the force RL by AE, that is the formula for elongation. So for second, load is applied R minus 2W, third load is applied R minus 3W. Like this we have calculated. So got R is equal to 5W by 3. So as we assumed the reaction at point A is R, so that R is calculated now. So this is the reaction, R is calculated 5W by 3. So here the concept is how to apply principle of superposition to determine the loads for individual sections. So here again reaction at lower end. So as we already defined the reactions at lower end R minus 3W, and here R is calculated. This R will be going to supply here 5W by 3 minus 3W minus 4W by 3. So whatever direction is taken for the reactions at lower end, that direction will change. Why? Because here value is calculated, this value came negative, so the direction going to change. Here minus 4W by 3 calculated. So as at the end of another third sections, here we have taken tensile force R minus 3W. So as calculated, it came negatives, means that it's going to become, if you draw it, it will be compressive force. It will be compressive in nature, and the reactions value will be 4W by 3. 4W by 3. So we can say here 4W by 3 as it is calculated. Okay, so this is the calculations. So reactions will be in opposite directions, okay, at the lower end. So this is done. So up to here, let's stop. Thank you.